talking about questions, does anyone know about math science? I bet a lot of you might know about math science from your local communities. But what you might not know is that we are the world's leading science enrichment provider for kids aged 3 to 12. So I bet you're a kid aged 3 to 12. So once again, this is the event for you. We have a global reach of 150 locations in over 20 countries and counting. We actually had kids from about 50 different countries register for this event. Some of those countries include USA, Canada, England, Philippines, India, Mexico. So give a wave to the other kids on the call from around the world. And if you didn't hear your country called, you can let us know where you're from in the comment section. Mad Science absolutely loves bringing fun and educational science programs to kids. We do birthday parties, after school programs, summer camps, workshops, events, and virtual events just like this one. So the fun doesn't have to stop here. So be sure to look out for Mad Science. Be sure to look out for Mad Science location near you. So that's it for me. That was a lot of information and there's lots of fun information coming your way. I am so thrilled to introduce and welcome back Dr. Quyen Hart. So let's all give a warm welcome. If you made your glasses, you can put them on. I have my glasses here. And if you didn't make your glasses, that's okay. You can give a warm welcome with some twinkling star hands. So welcome, Dr. Hart, and enjoy the show, everyone.
Good morning, everybody. Or afternoon. It's actually just turned afternoon for me here in the East Coast. Thank you very much, Jupiter Jen, for the warm welcome. As you heard, my name is Dr. Quyen Hart. I am at the Space Telescope Science Institute in Baltimore, Maryland, and I am a project scientist working on JWST Science Communications. And I'm so happy that I can start off the weekend with you all to talk about NASA's and the Canadian Space Agency and the European Space Agency's newest flagship telescope in space, the James Webb Space Telescope. So we're going to be learning about galaxies, and I'll be able to answer some of the great questions that you submitted already when you registered, but we'll have time for Q&A at the end, like Jupiter Jen said. So let's get started. So right now I see you, you see me, I can see the world. Our eyes, human eyes, can detect visible light. So you, maybe it's the trees, maybe it's the flowers, maybe it's fireworks, maybe it's your lovely pets. And that's the kind of light that human eyes can detect, visible light. But are there other kinds of light? Are there other kinds of light that we can't see? I'm pretty sure I see a lot of nods on the screen. Yeah, there are other kinds of light. For example, if you go to the dentist, maybe they'll take x-rays of your teeth. Or maybe if you broke a bone in your body, it'll take x-rays. Maybe you heard about radio waves. That's actually a kind of light too. How about gamma rays or ultraviolet light? They're all types of light. And here's a fancy word. You guys can all say it together with me. The electromagnetic spectrum. That could be your new word for the weekend. Now, I'm just going to jump in. I see some people are coloring on the presentation. So we're going to ask you to not make designs on the presentation because we need everybody to see what Dr. Hart is presenting. So if you guys cannot make designs on the presentation, that would be great. Thank you, Jupiter Jen. So let's say the word together again. Light, a fancy word for light, is the electromagnetic spectrum. And guess what? I shorten it to say EM spectrum because electromagnetic is a really long word. So light is the electromagnetic spectrum of light here. Visible is just one small piece, and there's a whole bunch of other kind of light that your eyes can't detect. So if we want to study space, we can study space using the light that your eyes can detect, the visible light, but we can also use telescopes to detect the other kinds of light that we can't see. So I want to talk to you today a little bit about infrared light, because that's really, really important for the James Webb Space Telescope. So we're going to learn about the power of infrared light, which is redder than red that your eyes cannot see. And I'm going to do a demonstration right now, and I'm going to have you guess. So this is where if you want to put your video on, if you have to guess number 1, 1 finger, 2, 2 fingers, or 3, 3 fingers. And that's how we're going to do this today, okay? So you can use either hand to do this, 1, 2, or 3 when you have to guess. We good? Okay, well, I'm going to stop sharing for a second here. Stop share. All right, so I have 3, let's see, move this for a second to this screen here. So I have 3 cups behind me over here. Do you guys all see that? Number 1, 2, and 3. Now, I'm just gonna show you what's inside. It's just water, okay? The other cup has water too. Now, the question I have for you is, which cup has the coldest water in it? Just using your eyes, okay? On the count of 3, the question is, which cup 1, 2, or 3 has the coldest water in it? Okay, ready? When I say go, you're going to guess. 1, 2, 3, go. Okay, put up your finger. Which cup do you think has the hottest water? I'm sorry, the coldest water. Cold, cold. I see 2s, I see 3s, I see 1s. Okay, well, guess what? Your eyes cannot see this at all, right? So what do we need? We need a special set of eyes, okay? Maybe they're going to be infrared eyes. So let's just pretend that these are your infrared eyes, okay? So I have a camera that can detect infrared light. Okay, so it's right behind here. Whoops. A little jiggling here. So here's an infrared camera. Let me move out of the way. So I have a camera that's sitting just over here, and it's pointing to the cups. And this is detecting infrared light. Your eyes can't see through that. And notice there's a cup that looks really dark blue, kind of bright yellow in the middle, and kind of in between. So number 1 is the in-between color. Number 2 is kind of bright yellow. And number 3 is kind of blue. So cup 3 has the coldest water in it, okay? It's not giving off that much infrared light, but your eyes couldn't see that, but this camera can. That's infrared light here. Now, I'm gonna turn off this for a second again. I don't think you can see through it, okay. Now, I have a trash bag. Can you see through the trash? Can you see the cups through the trash bag? Nah, I can't see through the cups, right? All right, let me see. I think, Jennifer, you can't see anything, okay. I'm just going to rearrange some stuff here.
I can't see anything. I don't think you guys can either.
Okay, so I'm still blocking this, right? Now this is going to be the cool thing. Your eyes can't see through the trash bag, but the infrared camera, let's see what it does. Ready? Whoop, let me get my hand out of the way. Look at that. Your eyes can't see through the trash bag, but it can see infrared light can get through the trash bag, and I can still see the cups. That's really cool that infrared light can pass through a trash bag to see the stuff behind it. That's very different than what your eyes can do. Okay, so now here's another cool thing. There's some material that can't see through infrared light. So here I just have a regular tub just laying around my house. All right, let me go back here to oh, there you go. All right. Oh, look at that. It can't really see through this plastic though. This is a little different than the trash bag. So infrared can't go through everything. The other part of infrared light, now this is really cool. I'm going to warm up my hands. So, you know, if it's cold outside and you're cold, rub it together. We're using a little friction to make my hand warm. Now, I'm gonna make a print on here, on this. Okay, can you see my handprint? Let's put it in front of the infrared camera. Infrared light can detect heat, like my handprint. Isn't that pretty cool? That's pretty cool, right? Now, the other thing that infrared light can do is detect things that are warm. Whoops. having technical difficulties. We're going to pass on that. But if I warm up the entire tub with my hairdryer, it would glow. So warm things also glow really, really bright in space, just like that warm red cup in the middle. All right. So now we have a little idea about what infrared light is. So I'm going to start sharing again. All right, if Jupiter Jen can confirm that you can see a single slide.
Yep, looks great.
Awesome. Okay, so what is the power of infrared light? Well, the power of infrared light here is that infrared light is like heat, like you saw with my handprint or with a warm cup of water. Okay, cold things give off a little bit less infrared light than warmer things. Our eyes can't see it, so we need some other kind of detector to be able to really sense it, even in your regular surroundings or even in space. And you can see through some materials that visible light can't. So I just demonstrated all that. That's really cool, the power of infrared light. Now, why is this so important to understand? It's because the James Webb Space Telescope is an infrared telescope. It is a big telescope. So this telescopes use mirrors to collect light, and it can focus that light to detectors that can sense it. This telescope mirror is quite large. If I were to lean it against something, it would be as tall as a 2-story building. 2 stories, it's really big. You can see that it's yellow, and that's because it is coated in gold, but very thin, not that much gold, about the same amount as about 5 gold rings. But we use gold because it reflects and collects the light really well in the infrared. Okay. Now, some people asked, how is it better or different compared to the Hubble Space Telescope? Well, the Hubble Space Telescope can detect not only visible light, it can detect ultraviolet light and a little bit of infrared. The mirror is also smaller and it orbits really close to Earth. Now, if I put the Hubble Space Telescope mirror and lean it up against something, I could actually lean it up in my office here on the wall. It would fit, but not that Webb Space Telescope. It's so big, it has individual mirrors, 18 of them in a hexagon shape. Webb here can only detect, it mostly detects infrared light, like really light that's redder than the red light that you can see. This telescope was launched on Christmas Day last year. It was something that we were so excited to watch, and you can watch the recording. I was up Christmas morning and it was the Christmas present for the whole world, a holiday present, and all the astronomers were just waiting for this to happen. Now, the telescope is so big that it actually was folded inside the nose of the rocket. And over the course of a month, it actually had to unfold. So we talk about unfolding the universe with Webb because it literally had to unfold. And it traveled to a place that's 4 times further away than the moon. So it took a long time to get there for that reason too. So this was all slow and everything worked amazingly well. So kudos to all the scientists, engineers, people on the ground making this happen to send this amazing technical marvel into space. Now, as you saw earlier, visible light allows you to see things in your environment, like those meerkats on the left, or like that freshwater crocodile on the right. But if I switch to infrared light, I start to see the world slightly differently. We can see that the meerkats, which are warm-blooded animals, glow really bright, but the water crocodiles don't compared to their environments. Okay, so the infrared light here allows us to see a different part of the universe. And the James Webb Space Telescope is sensitive to this infrared light and it can detect it. All right, now it's guessing game time. Everyone ready? Thumbs up if you're ready. Ready? Okay, so now we're going to play a guessing game. Okay, the guessing game today is for you to see some new images from the James Webb Space Telescope, which I'll shorten to the Webb Space Telescope. And I want you to guess, is it a star? And you'll do 1 finger. Is it a planet? You'll do 2 fingers. If it's a galaxy, 3 fingers. And if it's a gas cloud, you do 4 fingers, okay? So 1 is a star, 2 is a planet, 3 is a galaxy, 4 is a gas cloud. Are we ready? Okay, guessing game time. Let me just move this out of the way because I want to make sure I answer some questions that people have too, as they came in earlier. All right, ready? Here's our first one. All right, so this is an image from the JWST telescope out in space. It's from one of the instruments that we call the near infrared camera, or NIRCam. So if you think it's a star, 1 finger, planet 2 fingers, galaxy 3 fingers, gas cloud 4 fingers. On your mark, get set, guess. Jupiter Jen, if you can tell me how many fingers do you see that most people are answering?
I think I'm seeing a lot of 1s.
A lot of 1s, okay.
A couple of different answers, but majority say 1.
Okay, so a lot of people think it's a star. So let's go see. Oops, I don't know why it's going here. There we go. Oh, ding, 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 star, yay. So now this might look different than other stars that you've seen from the Hubble Space Telescope or telescopes on the ground. This is a really unique feature. Those spikes that you see are called diffraction spikes. That's a big word, but all you need to know is that it's special because of the shape of the telescope. It's a hexagon shape, and that allows these spiky things to be created. So they're actually not part of the star. It's actually because of the telescope that we get those spikes. Now, Brenna from Plainville and Raina from LA and Jessica from East Longmeadow ask, how are stars created and what are they made out of? Those are great questions. Well, a star is a giant ball of gas, mostly hydrogen, a little bit of helium, and like a smidge, a pinch of everything else. So it's gas, it's not solid. You couldn't walk on it. You wouldn't want to walk on it. It's really hot, okay? Now, how are they created? Well, you need a really big gas cloud, and somehow it has to come together by gravity to get denser and hotter, and then eventually it'll form its own energy, and boom, not a literal boom, it will become a star, and it creates its own energy. So those are great questions. All right, let's go to the next guessing, next slide for guessing. All right, again, here's an image from the Webb Space Telescope. It's taken with a NIRCam camera. It's a near infrared image. So do you think this is a star? 1 finger, 2 a planet, 3 a galaxy, or 4 a glass cloud? So on your mark, get set, guess.
Okay, I think most people have made their selection, and I think everybody said 2. A couple of people said different things, but I think majority said 2.
2, okay. Good work, everybody. This is great. We're learning today. And this is a very interesting image. It's of our friend Jupiter, a planet in our solar system. So this here, you can see, I don't know if you can see my cursor. There's a little white oval to the lower right hand side, and that is actually the red spot. But we call it the red spot because in visible light, it looks red, but in infrared light, we have to select colors for the colors we can't see. And here it appears white, but it's not actually, our eyes wouldn't see white because our eyes can't see infrared light. So this is there's a lot of artistic choices here in order to represent what infrared light would look like, so that you can have a picture of it. This is great. Let's see here, sorry. Their planet, and it's Jupiter. All right, next, ready? Okay, we have 2 more to guess here. So here we have a beautiful image that was released on July 12th. So not too long ago, it's July, August, September, so almost 3 months ago. It is a beautiful image. I love this image. This is real information from space, but taken in the infrared. Do you think 1, it's a star, 2, it's a planet, 3, it's a galaxy, or 4, that it's a gas cloud? Ready? Let's all think. On your mark, get set, guess.
Okay, so the results are coming in live. I see some 4s and some 3s. So this one wasn't as clear as the last one.
Okay, it's a little bit more complicated. So guess what? There's probably 2 answers here, maybe even 3. Now, the most features that you see here are the orangey color, and that's a lot of gas and dust and really complex molecules that are giving off infrared light. So this is actually in a gas cloud. But do you guys see those very distinct diffraction spikes that we saw earlier? There are definitely stars in this picture. So if you answered star, you're right. If you answered gas cloud, you're right. Now, there's actually a whole bunch of baby stars here, and maybe some stars with planets. We may not see them in this picture right now, but they're probably there. Now, the galaxy, this is not quite a galaxy, but let's get to understanding what that is. All right, and that's in the Carina Nebula. Now, last guessing here. So this is a Hubble Space Telescope image in visible light. Do you think 1, it's a star, 2, it's a planet, 3, it's a galaxy, or 4, that it's a gas cloud? Okay, get your thinking caps on the count. Get ready, on your mark, get set, 1, 2, 3, guess. All right, I see 3s. Jupiter Jen, what do you see?
I see a lot of 3s, and I think a couple of 4s, but a lot of 3s mostly.
Okay, awesome. So we've got, oops, I went backwards, went the wrong way. Yes, it is a galaxy. Excellent. So a galaxy here is a collection of hundreds of billions of stars, but it also has dust in it. It also has gas in it. Those stars probably have planets there. So all of the stars, planets, galaxies, and gas clouds, a galaxy is composed of a lot of that. Now, this is visible light. The James Webb Space Telescope took a picture. Let's take a look. Wow. This is different kind of light. Now I'm going to go back and forth. So you see here's the visible light. Like if you could actually see it, you might see something like this. But if you switch over to infrared, a lot of the dust that's warm gets picked up by the James Webb Space Telescope. Isn't that cool? That is really neat. So we're understanding a whole new way to understand the universe with the James Webb Space Telescope. Now, there are a couple people who asked, so Cambria and Marv from Altus asked, why can't we see other galaxies from Earth? Well, with your own eyes, they're really small and galaxies are really far away and faint. Now, you can actually see a different galaxy from Earth, but you have to go to a really dark place. So here's an image from Earth looking up at the night sky in a really dark place away from city lights. And you might see an oval-like smudge in the sky in the constellation of Andromeda. And that is the Andromeda Galaxy. It's the closest large galaxy to the Milky Way. If I were to put a telescope on that part of the sky, you might see the smudge. It's just above this tree here on the right-hand side. If I took a picture with using a visible camera, I would be able to see this. So you can see other galaxies from Earth. You just need the right detector. And they're so faint, you need telescopes. Your eyes have, now you might be able to use binoculars for some of those, but telescopes are really great. All right, great questions. All right, so this is showcase time. So I think Mad Science asked you to make your own creations of the James Webb Space Telescope images, either ones that you've seen or ones that you hope to see one day. So Jupiter Jen, how would you like to direct them?
Yeah, so does anyone who finished this drawing, so I'll hold up mine, I'll add a spotlight so you can see my paper.
And I'll show mine now too.
So this is what it looked like. Oh, there's a lot of stuff going on. This is what it looks like blank. So if you have that paper filled in and you want to, if we have time, if you want to tell us about it, you can hold yours up and we can spotlight you and you can tell us all about yours. So I'm going to go back to look and see if anyone has completed it. Oh yeah, there's so many beautiful, beautiful designs that I'm seeing. So I'm going to ask Talia if you want to tell us about what you created. So I'm going to ask you to unmute. I'm going to add a spotlight. Hi, Talia.
Hi.
Do you want to hold up what you did? And if you can, tell us a little bit about it.
I made a star with like gas in it, and that was this right here.
Cool. I like the labels.
Thank you. And I made a blasting star reflecting light and starlight.
Wow.
And I made the moon with moon dust on it.
It's very
So
cool,
cool.
Talia.
Thank you.
Thanks so much for sharing. So I'm going to see if I can add a couple more people to tell us about theirs. Jackson, if you're there, I'm going to ask you to unmute if you want to tell us a little bit about what you created.
Dr. Hart, can you turn off your screen for a minute, please, so we can see so everyone can see what the kids are writing or drawing?
So I made a galaxy. I made a giant galaxy with a black hole and 3 other small galaxies.
Mm-hmm. Very, very nice.
And then there's a giant star in the middle of it.
Very, very cool. Thank you for sharing. Okay. Do we have time, Dr. Hart, for one more, or should we continue?
Let's move on because we're going to start the creative section next.
Okay,
here.
perfect.
Yeah, let me share again. I think we'll have time near the end. And for those of you who weren't able to share right now, I'm going to love to see and get a good view of everyone's if you want to share later on. All right, thank you very much. You might have seen my artwork over here. Now this one is more of what visible light galaxy would be. I made this many years ago, so I have to make a new one that is about the infrared universe. So that's probably going to be my next piece of creativity. All right, so now I want to talk to you about making a galaxy with your modeling clay, slime, or plasticine that you might have. So today we're going to talk about galaxies. As I mentioned, galaxies are collections of hundreds of billions of stars together. But when astronomers look out at the universe, they saw that there were 2 different main types of galaxies. There was a galaxy that was called elliptical, that we can see the shape of it, and it might be circular or spherical in shape, or it might be elongated. So elliptical is one type of galaxy shape. Spiral galaxies, kind of like what I drew here, is another type of galaxy with spiral arms. And then guess what? If a galaxy doesn't have any of those features that would fit it into an elliptical or spiral, astronomers put them into the category of irregular. So irregulars can be many different things. And you see real images of those kind of galaxy types below. So this is when you want to take out your modeling clay, and we're going to work through this together. Now, some of you may have already started, but a really good starting point is making some rolls. Okay, so I have my clay here, and I'm just going to roll it out to make little rolls here. So go ahead. They can be thin, they could be thick, as much as you like. Now, I'm going to show some videos here so you can follow along if you're not sure how to make this. So thanks to our partners here at Mad Science, they made some stop caption movies for you to be able to see how to make spiral galaxies with either 2 arms or 4 arms. So you start with one of these rolls of clay, okay? And you can start spiraling them on each other. So the one on the left is how you can make a 2 spiral arm galaxy. If you want to make a 4 spiral arm galaxy, and this is very typical of what we see in space, then make 2 rolls of clay. And then galaxies are sprinkled with lots of dust clouds where stars are forming a lot. So you can even sprinkle them with places where you think star formation is happening. And That's what you see on the left there. So again, make rolls here. Roll it out. And then you can either follow along with the 2 spiral arm on the left or the 4 spiral arm on the right. So I'm going to show you my quick one here. So here's my quick spiral galaxy. All right. Now, there's another kind of really interesting spiral galaxy. It's called a barred spiral galaxy. So on the left, there's actually galaxies that look like they have a bar in the middle, and then the arms come off of it. So if you want to make the middle part more rectangular, and then you make little arms that come off the side there, you have a barred spiral galaxy. Turns out that our own Milky Way galaxy is a barred spiral galaxy. It's pretty cool, huh? And we know that by understanding all the stars and how they move by using telescopes. Now, elliptical galaxy. So for those of you who might have want to try an elliptical galaxy, it's really easy. Okay, here's mine. Ready? Boom. Elliptical galaxy made of hundreds of billions of stars in a spherical shape. Now, sometimes ellipticals are a little bit more elongated, like a football maybe. And so what you see in the video on the right there is the elongated elliptical galaxy. Okay. Now, if I look at it down the barrel, it looks circular. So this is also, how do we see it in space? Which angle are we seeing it? So Jupiter Jen, we want to see their creations right now?
Yeah, so if anyone was able to create some, you could just hold it up and we won't unmute you, but I can spotlight some people if you want to hold up your creations. I'm going to go to, there you go. Very, very cool. Hi, thanks for joining. Okay, so I'm going to look at my gallery here. I wish I was slightly faster so I could spotlight everyone. Okay, I'm going to go to Letitia. And we can even try, hi Letitia, we can even try and guess the type of galaxy that was created based on the information that we just shared. Okay, I'm gonna go to maybe one more. So I'm gonna look through my screen and see, okay, I'm gonna go to Javier, add a spotlight. Give us a wave. Hi, you wanna hold up your creation? Very, very nice. Thank you for sharing. Okay, so thanks everyone. You guys can continue to make those. If you made one type, you can, as we continue the event, you can make a different type, and you can always hold them up so we can see over here what you guys are making.
Yeah, that's great. I saw some spiral arms that looked more wrapped than others, and guess what? That really happens in space. Sometimes spiral arms are a little bit more loose. That really happens in space too. So for every kind of galaxy that I am seeing that you're creating, most likely it exists in space. So let's see some examples. So here's a nice spiral galaxy, real one on the left, and our creation on the right. Here is one of those barred spiral galaxies, real image on the left and creation on the right. How cool is that, that you're making models of what galaxies look like? Okay. Now, actually, how you created it might be the reality of it. So I have somebody's question I'll answer in a second here about how galaxies are actually created. Here's an elliptical galaxy. Notice with elliptical galaxies, there's not as much, there's no arms. There's actually not that much dust and gas. They're actually composed of lots of old stars. Okay, so here's one example of an elliptical galaxy that's looks a little longer. Here's one where it's more circular. Okay. Now, a question that someone asked was, now you might see in this elliptical galaxy, the real image on the left, there looks to be like a blue jet coming out. That's actually a jet coming out of a super massive black hole at the center of that elliptical galaxy. Most galaxies have super massive black holes at their centers. And sometimes they're really rambunctious and really active, and they can spew out lots of energy and light that we can detect. So see here. So Alicia from Commerce Township, Hickam from Agadir, and Edwin from Montreal ask, can we see a black hole? How many black holes are in a galaxy? And what is the biggest black hole in a galaxy? Well, let me ask the first question. Answer, can we see a black hole? We can't see black holes because black holes don't emit light, but they create gravity and they can interact with the surroundings to emit light that we can see. But the black hole itself, we have no detection of light because light can't be emitted from a black hole. The image that you see on the left is an infrared detection of stars moving around the center of our own Milky Way galaxy. There is a 4 million times more massive than the sun supermassive black hole at the center there. And we know that because it's making those stars go around it really fast. So black holes have gravity and stars can move around it. So we know it's there. We can do this for other galaxies too. Now on the right-hand side is a distant galaxy, a galaxy outside of our own Milky Way galaxy. And if we look in different kinds of light, this is visible light, but if we switch to infrared, we see a lot of the dust. If we switch to radio, we see these jets. They're coming out from the supermassive black hole at the center, and it actually can create a lot of energetic light that we can detect. So astronomers do this a lot. They study the universe in all different kinds of light. So those are great questions coming from everyone about black holes. Here's an irregular galaxy. No real shape. There's no dust. Well, there's actually a lot of dust, but there's no spiral arms. When there's dust and there's gas, there's stars that are forming. And so this could look like a hodgepodge of things. This could be an irregular galaxy, a model. Okay, let's see here. Oops. Okay. Now, question came from Joaquin in Texas and Saditha for Colombo and Nicole from Johnstown. They asked, how are galaxies formed? Well, like I said, galaxies are formed. Galaxies contain a lot of stars and planets and gas and dust clouds. So at the end of the day, a galaxy needs to form out of a giant cloud so that a whole bunch of stars can form, and then the stars are together due to gravity. But then if we have young galaxies near each other, so all the yellow pieces that you see in this model, the simulation that uses our understanding of how the universe works, galaxies actually merge together to grow into larger galaxies. And sometimes the end result is that it looks like an elliptical galaxy. Sometimes it looks like a spiral galaxy. Sometimes it's just really weird and it looks like an irregular galaxy. So they're formed by first the stars, and then they grow by merging with other galaxies. Now here's another example of what this might look like. So again, this is a simulation, a model that scientists put together of two galaxies colliding with each other. And what you'll see is they'll stop and then show you an example of what it looks like in real space, in space for real. These are optical images that you see right now. So these two galaxies are colliding over time, and they change their shape. Sometimes they go right through each other. Now, galaxies are mostly stars. They actually don't really like collide and knock against each other. They kind of flow past each other, but gas clouds, they get compressed. And when they get compressed, they get hot. And when they get hot, they form stars. And so a lot of these collisions are lit up like fireworks with lots of new stars being formed. So this is pretty cool that we as scientists can understand all the rules of physics to create a computer model and then see how that reflects the universe. Because all of this takes a long time to happen, billions of years. So we can't watch one of galaxies do this, but we can watch different types of galaxies and make put the puzzle pieces together. Okay, let me move on to the next slide here. All right. So I want to talk to you about one of the images from James Webb Space Telescope called Stephan's Quintet. This is a visible light image of Stephan's Quintet. We see there's 5 images, 5 galaxies. So all the yellowy clumps and the blue-green clump that you see, those are all individual galaxies. The yellow ones that you see here are the ones that are grouped together. There's actually a fifth one, which is not in this frame, but they're together in space in really tight quarters, really close to each other, so much that they are interacting or colliding with each other. So what did the James Webb Space Telescope see? Okay, so again, these are stars. I see some dust clouds. I see some fireworks of star formation. And just like in the beginning, when you saw how an infrared telescope can see warm things or see through things, let's look at this middle here. Do you see this dust lane that kind of looks like a smile? Let's see if we can see through it with the James Webb Space Telescope. Again, these are real pictures of space. We can. So I'm going to go back and forth here. So that's a visible, the light that your eyes could see. And notice I could see through the dust clouds and see some more stars. Now this is in the what we call the near infrared. It's just a little redder than red. What if I use the camera to see warm dust glowing? What would that look like? Looks completely different. So I'm going to go back. This is still James Webb. This is visible light from the Hubble Space Telescope. And notice that the features change. I could see through the dust with this infrared image. Then I could see the glowing, warm dust here. Now I love this Stephan's Quintet because can you spy the smiley face? Hello, smiley face. So those two galaxies are actually colliding with each other. So if I were to smash them together, boom, smash, gets lots of star formation. I actually could see a lot of the gas and dust actually colliding. And this allows us, the astronomers, to understand how this happens, how it can create the universe that we see in the galaxies. This is really important to understand the early parts of the universe. So again, the power of the infrared is that we can see through dust and understand the dust. Just like what I showed you earlier, I can detect warm things and cooler things. I could see through the trash bag. I could see through the dust, and then I can actually see the dust and complex molecules actually glowing in the infrared, giving us a lot of information here. So there was a question here from Ruby from Burbank and Cameron from about how big is space? Wow, that's a really great question. Space is pretty darn big. It's really never ending. I like to tell everybody that this universe is not something I can measure. It goes on forever in all directions. It's bigger than that. We're just one planet of 8 around one star in a galaxy that has hundreds of billions of stars. That's just us. Now imagine this, imagine you had to go, let me just stop here. So imagine that you had to go to every single beach on every part of the earth and count every single individual piece of sand. You still wouldn't count up as many galaxies as there are in the universe. That is how big it is. It's bigger than I can even imagine. So for those who ask that question, I can't even imagine. I think it's so amazing that we can study the universe from right here on our planet, orbiting around a star. So I think that is the end of my presentation. So thank you all for listening.
Thank you. That was awesome. Let's all give a round of applause. Yay, that was so interesting. And we still have a bit more time. So we are going to get in some live questions. Actually, I think to kick off the Q&A, I have a question which I think might be very interesting to everyone on the call.
Right.
Dr. Hart, since you have such an interesting job, we want to know, and Xavier sent in this question. Xavier W wants to know, what is your most favorite part of your job?
Oh, well, I really love talking to people about the wonders of the universe. So what I'm doing right now with you all is actually really one of my favorite things to do, is having you all ask me questions so I can share what I know and the things I don't know. I don't know everything. Not everyone knows everything. But to be able to say how things work is amazing. And the fact that we can do it with using our brains and our technology to understand the world out there, that big universe out there. The other really fun part of my job is that I get to see some of the images from the James Webb Space Telescope before they're released to the public. So a lot of the news that you see, I work with people who run the news office, and we talk a lot about the really cool science like galaxies that are coming out. So that's a really, really fun part of my job as well.
Okay, so let's take a live question. So I'm going to look for raised hands. See if you can put your arm up to the sky super high, and I will ask some live questions. So I'm going to go to Gary. So I'm going to ask you to unmute. Gary, you're sitting a little far from your screen, so you might need to get a little bit closer. What is your question?
How did space got formed?
Oh, that's a how did space get formed? You know what, Gary, you can be one of the scientists, one of the theoretical scientists who try to figure out how was space formed. So space is everything that exists out there, right? We are existing in space, but back in time, in the past, the actual distances between things were a lot closer together. Okay, so it was really dense. We don't know what started the universe. We know that something called the Big Bang happened to unfold and create the universe that we see today. And we have lots of great science to explain most of that until just before the Big Bang. So space is something that people are still trying to study. So I don't have a great answer for that. But space might have some energy associated with it. It might be related to something called dark energy that we have no idea what it is. Maybe space is involved with that, the actual fabric of what we say, the fabric of space itself. Great question, Gary.
I did myself, sorry. So I'm looking for hands raised to the sky. We're going to try and answer as many as we can. So I'm going to go to Thomas. Thomas, if you want to unmute yourself. Hi, Thomas.
There we go.
What is the biggest spacecraft ever invented?
Whoa. You mean space telescope?
Yeah.
The James Webb Space Telescope is the biggest telescope in space. So I said that the mirror could fit and lean against a 2-story building, but the actual observatory, we have to shield it from the warmth of the sun and the earth and the moon. Someone asked, can we see the moon with the James Webb Space Telescope? We never want to look at the moon. It's too bright, it's too warm. We don't want to destroy our instruments. The telescope exists in a structure that's as big as a tennis court. So if you're at a tennis court, the whole observatory itself, the mirror and all the instruments and what we call the sun shield is quite large. So it's the biggest space telescope. On Earth, the biggest telescopes are actually radio telescopes. So if you were to ask me the biggest telescope ever invented, whether it's on the Earth or in space, a single, like one telescope, it's a radio telescope. I believe it's in China. But astronomers and scientists are really, really inventive, and we can actually create an array of telescopes to be like one giant telescope that acts like the same size as the Earth, but it's not physically the same size as the Earth. So that's a really cool question.
Thanks, Thomas.
So maybe one more question, Jupiter Jen. We have 5 minutes to the top of the hour. Does that work for you?
Yeah, sure. I'm actually going to go to the chat because we have a lot of kids who don't have their screens on. So I'm going to go to the chat, and we had a very cool question when we gathered questions on Zoom as well. Lots of people were interested in black holes. So I have a question that says, can we send a telescope into a black hole?
Wow, that's a really great question. So one that's never happened before. There's no plans to do that. It takes a really long time to send anything to things in space. We have only sent humans to the moon, okay? For reference, remember the James Webb Space Telescope is 4 times further away, but humans have only gotten to the moon, and we haven't done it recently. It would probably take the better part of a year for us to get to Mars. If you can travel as fast as the speed of light, it would take you 4 years just to get to the nearest star, going at the top speed of the universe, which we can't even do either. So no, we have not sent any telescopes into a black hole. Now, imagine if we did. Let's say we got past all those challenges and we sent a telescope into a black hole. Well, we would need to get the information from the telescope to understand what was happening. And the thing is, a black hole, you have to travel faster than the speed of light to get out of a black hole. And so even information from a telescope could not escape from the gravity of the black hole. So it's not very useful for us either. So what astronomers do is that we point telescopes and look at the things around the black hole. And that's how we understand black holes. And we have lots of evidence that black holes exist, from ones that are just a little bit more massive than the sun to ones that are a million times as massive as the sun. Lots of strong evidence for it.
Thank you so much. So unfortunately, we have run out of time for our question and answer period, but I'm sure that you all have super interesting questions, and we do encourage you to seek out the answers to your questions. You can ask a grown-up, you can ask your friends, you can look for the answers from your teachers on the internet. So we hope that your questions are answered, and you can even contact us on our Facebook page if you have some questions that you still want to ask. So at the moment, I am going to do the prize giveaway. So we are giving away our STEM subscription box, and that is Loop Lab. So the winner will get our gross science subscription box, and you can make a foaming fountain, and you can make a DIY ooze ball, and you can make some really yucky ghost goo. So I have my container here. It's a compost bin. There's no compost in it, so that's really good. So I'm going to mix up all of the people on the call, and I'm going to pull out 2 lucky winners. So I'm going to ask you guys to do a drum roll on your table. So drum roll, please. Thank you very much. The first winner is Cesar or Caesar R. So congratulations to Caesar. Yeah, and round of applause. Okay, and we have one lucky winner, one lucky winner left. So I'll ask you to do another drum roll. The next winner is Kylene A. So congrats to our lucky winners. You're all winners in my eyes. Thank you very much. I'm going to share my screen because we didn't get to see all of your creations. So I do want to encourage you to share your creation. So if everyone can see my screen, you can send us what you created on our Facebook page at Mad Science. You can share it on our Instagram page at Mad Science Group. We have someone who submitted their drawing below. And you can also actually submit your creations to NASA's Unfold the Universe challenge. So that's this collection of images below. It's a public art challenge, and they would really love to see what you guys have created, and they will share your results on their page as well. So you can Google Unfold the Universe from NASA for that. So that's it for us.
Another tag, Jupiter Jen, is JWST Art. That will actually capture the attention of NASA because they are looking for JWST Art. So tag not only Unfold the Universe, but also JWST Art.
So I will actually throw it back to you, Dr. Hart, to say goodbye, and then I'll say some thank yous at the very end.
Yeah. Well, I hope you all had a great start to your Saturday. I know I did. I loved being able to share the wonders of Webb and colliding galaxies with you all. So you can ask your guardians to keep looking out at webbtelescope.org or nasa.gov for the newest images and other types of information from the James Webb Space Telescope. It is a super exciting time, and you all, being the future scientists and engineers of the world, the universe is going to be more understood by the time you all are being the scientists creating the next generation of telescopes. So I'm so excited. So thank you for joining us today.
Thank you so much, Dr. Hart. So I have 4 thank yous to say, so I'm going to remember them all. So the first thank you is to the team at Mad Science. Thank you so much for putting this together. The second thank you is to the Goddard Space, let me try to get this out, NASA's Goddard Space Flight Center. Thank you so much to their team for helping us organize this event. The second last thank you, of course, is to Dr. Hart for all of her time today. She had a great presentation. I could tell that you guys all enjoyed it. So thank you so much. And my last thank you is to all of you, all of the kids out there. Thank you so much for joining us. We hope to see you next time, and I'm going to let everyone mute their self for our goodbye. You can also hold up your artwork, and you can put on your glasses if you have them. So let me just unmute you all. I will unmute everyone. In 3, 2, 1, you'll be able to unmute yourself and say bye. Bye, thank you.
Bye.
See you next time.
Thank
Thank you.
Bye, everybody.
Thank you.
Bye, scientists of the world.
Thank you.
That was fun.
Thank you. Was fun. I agree.
Bye, everybody.
Bye.